Empirical formula and molecular formula. Now every compound has certain elements and the atoms of these elements are present in a fixed ratio. If we represent these atoms in simplest whole number ratio, then it is referred to as empirical formula. If we can show the exact number of each atom, then you call it as molecular formula. Say for example, C6H12O6. This will be the molecular formula for glucose, because here we are showing exactly what elements are present and how many atoms of each element are present. But if we take the simplest ratio of this, it becomes CH2O. The simplest ratio here is 1:2:1. So if we represent the atoms of these elements in simplest ratio, then it is the empirical formula. So this is the empirical formula for glucose, where we know what elements are present, but we don't know exactly how many atoms are present in one molecule. Let us see how to calculate empirical formula and molecular formula with the help of this question. Molecular formula is equal to n into empirical formula, where n is an integer. So first we need to calculate the empirical formula, then the integer. So once we multiply those two, we will get the molecular formula. Now the best and the easiest way to solve these numericals is by plotting this type of table. So in the first column, we will write the elements which are mentioned in the question. In the second column, we'll write the percentages. That's the mass percentage. In the third column, we will convert that mass percentage to grams. Now it is easier to assume that we have 100 grams of the compound. With that, we can easily convert 4.07 to 4.07 grams. Similarly, carbon 24.27 percentage becomes 24.27 grams and chlorine becomes 71.65 grams. Then in the fourth column, we have the atomic masses. We start calculating from the fifth column. In the fifth column, we are finding out the number of moles, for which the formula is given mass by molar mass. Number of moles gives us a relative number of atoms. It gives us relative number of atoms in a molecule. So this is our given mass, the third column, and our fourth column is the molar mass. So 4.07 by 1, 24.27 by 12, 71.65 by 35.5. So we find the number of moles. The next step is to look at the moles very carefully and see which one is the smallest. You need to find out the smallest number of moles. To find the simplest atomic ratio, we divide the moles that we have calculated in the previous column by the simplest mole or the smallest mole. So it becomes 4.07 by 2.01, 2.02 by 2.01, and 2.01 by 2.01. You are not supposed to round off the numbers here. So once the moles are divided into smallest mole, you get the simplest atomic ratio, which can be rounded off to the nearest number to get the simplest whole number ratio. Like 2.02 is rounded off to 2, and this is 1.004, which is rounded off to 1, and this is exactly 1. So we get the simplest ratio as 2 is to 1 is to 1. And we need to be very careful about the elements. We should not mix up the elements and the ratio that we have got. So this 2 is to 1 is to 1 is for hydrogen, is to carbon, is to chlorine. We got the simplest ratio, 2 is to 1 is to 1. Now these numbers that we have calculated, the ratio that we have calculated, has to be represented as subscripts. So it will be H2, C1, Cl1. And if the subscript is 1, we need not represent it. So the empirical formula will be CH2Cl. Now we know the empirical formula, so we need to start calculating the value for N. N is equal to molar mass by empirical formula mass. Now molar mass is already given in the question. We need to calculate the empirical formula mass. We know the empirical formula CH2Cl. So we just need to add up the atomic masses, and we need to make sure that we consider the subscripts because it gives you the number of atoms of that element in the compound. So it will be 12 plus 2 into 1 plus 35.5, which comes to 49.5 grams. So this value we will substitute in this formula and we will find out the value of N. Molar mass given in the question is 98.96. So that divided by the empirical formula mass, the value comes to 1.999, which is of course rounded off to the whole number value, that is 2. So the value of N is 2 in this case. For this numerical, the value of N is 2. Now we need to find out the molecular formula. We have the value of N and we have the value of and we know the empirical formula. So that will be 2 into CH2Cl. Now one thing you need to remember here is it is not like balancing equations where a suitable number is taken and all the coefficients are multiplied to get the balanced equation. Here this number 2 is multiplied with the subscripts to get the molecular formula. So the molecular formula will be 2 into 1, that will be C2, 2 into 2, that will be H4, and 2 into 1, that is Cl2. So that is our molecular formula. Here we have a practice problem. We need to find out the molecular formula of an oxide of iron. So we have only two elements here, iron and oxygen. Try to solve this numerical and post your answers in the comments section below.